All right, hey guys, sorry it cut me off and I tried to rush, but I'm going to come back to step 4. So we want to plug in, we want to find out what f of negative x is. Because if it's the same function, then we have symmetry over our y-axis. If it's the opposite of this function, then we have symmetry over the origin, so it kind of tells you how to be symmetrical with your graph, if one of those occurs. So we had negative x cubed 3 times negative x squared. So here you wind up with negative x cubed, because negative x times negative x times negative x. Here you wind up with positive x squared times negative 3 is negative 3x squared. So here, it's not completely the opposite. It's close, like we had the opposite, but this would have had to been a plus 3x squared. So we don't have symmetry over the x-axis or the origin. So we don't have that going on for us. And then step 5 is to find out your maximum number of turns. So max turns in your graph is whatever your degree is minus 1. So you can have 2 turns. And that means you're heading up, you turn down. That's 1 turn. So let's go ahead and get some graphing going on here. And this is just, you're winging it, okay? You're getting your main parts, but the squiggles in between don't necessarily, we don't know exactly where those wind up. So we know our x-intercept is at 0 and 1, 2, 3. We know my y-intercept is at 0, and that's pretty much where we're at. So we're going to start heading down, right? We're going to head our way up. And then remember, when you hit this one, we're going to say our multiplicity was 2. We're going to bounce. So we're not going to go through it. We're going to bounce. Now, how far do you bounce? We don't know. There was 1 turn. We got to come back around. Oops. Eventually. So there was 1 turn, 2 turns. And when we hit x equals 3, our multiplicity was 1. We're going to cross through that point. And that's a generic graph. Now, what happened right here? This could be way further down. This could be way closer. That stuff's not as exact. We're worried about the end behavior, the bounces and the crossovers, and what's happening to your graph that way. All right, let's try another one. So we're going to start off with our leading coefficient. It's going to be a 2, positive. And our degree is, we got an x squared times an x, so it's going to be x cubed. It's going to be odd. So we're positive odd. We're heading the same direction. What's next? X-intercept. Remember, your y is 0. We're going to kind of just do these out loud instead of writing them all out. We have x plus 2 equals 0, so x equals negative 2, and our multiplicity is 2, which means we're going to bounce. X minus 3 equals 0, so x equals 3. My multiplicity is 1, so we're going to cross. All right, let's move on to y-intercept. So our x is 0, so y equals 2, 0 plus 2 squared times x minus 3. Oops, 0. 0 minus 3. What do we got? 2 squared is 4 times 2 is 8 times negative 3, negative 24. Right, y equals negative 24. There's my y-intercept. Our turning points. Max number of turning points would be 3 minus 1, right? Because our variable, our degree was 3. 3 minus 1 is 2. So let's go graph. We got everything we need. Minus 2 plus 3. And minus 24, we're going to say it's down here somewhere. I'm just going to write the negative 24. All right, so we're going to start heading up. Head up to that point. Once we hit negative 2, we know our multiplicity was 2, so we're going to bounce. And eventually, somewhere down here, we're going to cross negative 24. We got to head our way back up. And at 3, our multiplicity was 1, so we're going to cross. Again, this could come down here. This could be way lower. This could be way wider. That part, not so much. We're just getting a generic feel of what the graph should look like. All right, bye guys.